All right, so we've been practicing with integrals, which is area under the curve. But how about sometimes when the area is a little bit different? Like look at this one, for example. They want us to find the blue region, all right, the area of the blue region, which is not underneath the curve. As a matter of fact, it's everything except for what is underneath the curve. Okay, so we need to use some problem-solving skills here. I'm going to offer up two approaches for how to do this one. Here's the first one. Let's find the area of the whole rectangle, which is pretty easy, right? That's a rectangle, so that's going to be 80. And then let's subtract off this piece, and then let's subtract off this piece. All right, so the only thing that'll be left is this blue area and this blue area. Okay, so if we do that, if we find the area of the whole thing, then subtract off this area, and then subtract off this area, we'll be left with the area of the blue. Okay, so this is one possible technique, and then I'll show you the other. Okay, so let's do it. So let's figure out this area. It's going to be the area of the rectangle. So let's see, base times height, so 10 times 8, minus the integral of x cubed dx. Now we need to figure out the limits of integration here, right? So 0 is the lower boundary, and the upper boundary is 2. And then from this, we also want to subtract off some more area. We want to subtract off this one. So we want to subtract off the integral of 10 minus x, because that's this function, dx, and its limits are from 2 to 10. Okay, so let's go ahead and do this. Let's figure out what this area is. All right, so the area is 80 minus, all right, let's figure out the antiderivative of x cubed. All right, so remember we kick it up a power, so it's going to become x to the fourth, and then we divide by that new power. So it's going to be 1/4 x to the fourth, and we're going to evaluate it 0 and 2. All right, let's put that all in parentheses so we don't get subtraction messed up here. And then let's do it again. Let's figure out the antiderivative of 10 minus x. So that's going to be 10x minus, kick it up a power, so it's going to be x squared, but now we have to divide by that new exponent, so 1/2. All right, and we're going to evaluate this guy from 2 to 10. All right, so now let's go through the algebra of this. Let's see, am I going to need new? Yeah, probably. All right, so the area is going to be 80 minus 1/4. Since it's a constant, I can pull that out, of 2 to the fourth minus 0 to the fourth. Minus, let's see, I'm going to need a ton of room here, so see if you can follow with me. Minus, I'm going to do all this in parentheses. 10 times 10 minus 1/2 10 squared minus 10 times 2. I'm going to put this all in parentheses, minus 1/2 2 squared, close parentheses. All right, so look at all these parentheses. This is a mess, right? And I even have to close off these brackets too. All right, so we got to be really careful there. It'd be helpful if I had more space here, but I didn't set it up so well. All right, so let's see here. 80 minus 1/4 times 2 to the fourth. 2, 4, 8, 16. So that's going to be 16, and we know that 0 to the fourth is 0. Now we got minus. Got to keep track of all these parentheses now. So 10 times 10 is 100. 10 squared is 100, but we're going to go minus 50 there. We're going to go minus, we got our brackets now, 20 minus 2 squared is 4, but half of that is just 2. Bracket, close parentheses. All right, let's see if I can still keep up this consistency here with the negative signs. 80 minus 4 minus 20 minus 2 is 18. So we got 100 minus 50 is 50, and then we got 50 minus 18, so that's going to be 32. So our area is going to be 80 minus 4, so 76. 76 minus 32 is going to be 44 units squared. All right, so I think we probably got it right. Let's check it with GeoGebra. All right, so you can see now I've got this set up with GeoGebra. The area of this big thing is obviously 80, and then this area I calculated right here is 4, and this area I calculated right here is 32. So remember we did 80 minus 4 minus 32, And what did that give us? Gave us 44, right? All right, now I'm going to show you a second approach, and this is a little bit of foreshadowing. We haven't totally learned this yet, but I'm going to foreshadow a little bit, so maybe when we get there, it won't seem so daunting, although I don't think you'll find it very daunting anyway. Okay, what I'm going to do in this case, let me put my ink on here. How about purple? What I'm going to do in this case is directly find this area and directly find this area and then add them together. Okay, so this is what this technique looks like. I'm not going to explain it in all its detail because, like I said, this is just foreshadowing. I don't expect you to have it perfected by now. Okay, so what we're going to do here is we're going to take the integral and we're going to go the top line minus the bottom. Okay, so if I were to draw a bunch of lines here, they all have the same top, which is this line, and they all have the same bottom, which is this curve. Okay, the top has a value of 8, and the bottom has a value of x cubed. All right, and that happens from 0 to 2. I'm going to dx that. All right, then I'm going to add on this area. All right, this one has a top of 8 minus the bottom, which is 10 minus x. And I'm going to integrate that from 2 to 10. Okay, so what I'm doing now is I'm directly finding this area and directly finding this area, and hopefully we should get the same thing. Let's see if we do. All right, so the antiderivative of 8 is 8x. The antiderivative of x cubed is 1/4 x to the 4th. I'm going to evaluate that from 0 to 2. And kind of to save some space, I'm going to do this part first, and then I'm going to do this part. Okay, so 8x evaluated at 2 is 16. 2 squared, or I'm sorry, 2 to the 4th, remember we said was 16, so we need 1/4 of that, so minus 4. And then when we plug in 0, we're going to get 0, right? Okay, so the area of this part right here is 12. Now let's do this part. And actually, I am going to evaluate this integral, but this is probably easier to figure out just that it's a triangle, right? Where the length here is 8 and the length here is 8. So it should be 1/2, 8 times 8, so 4 times 8, which is going to give us 32. So hopefully we'll get 32. But let's go the long way. Since we're doing calculus, let's practice the calculus. Okay, I'm going to simplify a little bit here. So we want to take the integral from 2 to 10. 8 minus 10 is -2, and then 8 minus negative x, so minus negative x is going to be plus x. All right, so we want to take the integral of that one. Okay, so we're going to have -2x plus 1/2 x squared evaluated from 2 to 10. So let's plug in 10. When we plug in 10, we get -20. 10 squared is 100. Half of that is 50. I'm going to do subtraction. Plug in 2, get -4. Plug in 2. 2 squared is 4. Half of that is 2. All right, so -20. Well, let's do parentheses first. Let's take our time. -4 plus 2 is -2, so that turns into plus 2. So we're going to have -20 plus 50 gives us 30. 30 plus 2 gives us 32. All right, so like we said, this triangle should give us 32, right? So the area of this is 12. The area of this is 32. So the entire area of the blue region is going to be 44 units squared, just like we said in the first slide and just like GeoGebra said. All right, if you have any questions, as always, write them down.